The engine coolant temperature sensor, or ECT sensor, is one of the most critical components in your vehicle's engine management system. This small but vital device continuously monitors your engine's coolant temperature. The ECT sensor operates as a thermistor, a special type of resistor that changes its electrical resistance based on temperature. It uses what's called a negative temperature coefficient principle. Here's how the electrical system works. The engine control unit sends a 5-volt reference signal to the sensor. As the coolant temperature changes, the sensor modulates this voltage signal back to the ECU. The ECU uses this temperature data for several critical functions: managing fuel injection timing, controlling cooling fan operation, and preventing dangerous engine overheating. Modern ECT sensors have significantly improved over older models. Today's sensors offer precision within plus or minus 2 degrees Celsius and can last between 100,000 to 150,000 miles. When an ECT sensor fails, it can cause serious problems, including engine overheating, poor fuel economy, rough idling, and will typically trigger the check engine light on your dashboard. When an ECT sensor begins to fail, your vehicle will display several warning signs that indicate trouble with the cooling system's temperature monitoring. The most obvious symptom is engine overheating, as shown by your temperature gauge reading in the red zone. This happens because the faulty sensor prevents proper cooling system activation. Another key indicator is the check engine light, which will illuminate with specific diagnostic trouble codes ranging from P0115 to P0119, all related to ECT sensor circuit problems. Additional symptoms include poor fuel economy due to incorrect fuel injection timing, rough idling as the engine struggles to maintain proper speed, and difficulty starting, especially in cold weather conditions. ECT sensor failures stem from two main categories of problems. Understanding these causes helps in both diagnosis and prevention. Electrical issues account for 60% of all ECT sensor failures. These include corrosion at electrical connectors due to moisture, damaged wiring harnesses from heat or vibration, and ECU voltage supply irregularities. Mechanical issues cause the remaining 40% of failures. Repeated heating and cooling cycles cause material fatigue, coolant contamination affects sensor accuracy, and physical damage from impact or vibration can destroy the sensor housing. Proper diagnosis follows a systematic approach. Start with an OBD2 scanner to check for diagnostic trouble codes, specifically looking for codes P0115 through P0119, which indicate ECT sensor circuit problems. Next, perform resistance testing to verify the sensor changes resistance properly at different temperatures. This requires a multimeter and temperature reference chart for your specific vehicle. Finally, conduct a thorough visual inspection of the sensor and its connections. Look for signs of corrosion on the electrical connector, physical damage to the sensor body, or coolant leaks around the installation point. Prevention is always better than repair. Regular coolant changes every 30 to 50,000 miles using manufacturer-specified coolant formulations will significantly extend sensor life. Additionally, applying dielectric grease to electrical connections during maintenance helps prevent corrosion and ensures reliable sensor operation.